Hello friends, welcome back to Geeky Sanjay. It's been a long time since we last connected. I have been very busy with my hectic schedule and studies, but I hope you all are doing well. Today I am really excited to share my HLT interview experience. We will be discussing the WhatsApp system, the hidden expectation of the interviewer, and how I prepared for it. Let's get started. So as I told you, the hidden expectation of the interviewer, you can see we have a long list and we will go through it one by one. And while we are just go ahead with this video, I will explain everything. So please be patient. This video can be a long video, but whenever we require the important knowledge, then long video is also good. Okay, so please bear with me. So I'll just continue with here. So the interview expectation, I have gathered all the expectation from based on the feedback they have given for the interviews. So I just listed down all the requirement, whatever they want to us. So first is gather both functional and non-functional requirements. Next, we have a estimate, scale, and perform accurate back of the envelope calculations. Third, we have a determine if the system is read heavy or write heavy. Then fourth, we have to tell him the actual storage is required for the system. Fifth, we have to identify like sharding is required or not. Then we have to find it out the bandwidth is requirement. Then next we have a justification for choosing either SQL or not SQL database. Then we have to design a high level component architecture and provide explanation for all the things and list all the APIs. Design a high level database schema like you have to explain him what are the table is required. Then create a complete system design with all necessary components. And we have to explain him the trade-off, like if system is distributed and so like what trade-off we will take it. And then last, the important thing, they want as a scalability identify at least one major issue with the proposed solutions. So these are the expectation set by the users, the interviewer. So we go ahead one by one. First, they have given me a design of WhatsApp system, and then I just think of the five-step approach to high-level design. First is problem statement, then requirement gathering, functional requirement, MVP. Then third is a non-functional requirement where we just see the design goals and then scale estimation and system design. So these are the five steps we normally follow. So first, we already know the WhatsApp is well-known application. So me and interviewer both are aware about it. So I think we can start directly with the MVP features. So in the next, like functional requirement, MBV features, so WhatsApp has only two MBV features as per my knowledge, supported one-to-one chat, and the second is group chat. Okay, where I just written the constant. If you want, you can write. Otherwise, no problem. Like maximum 100 people. So that doesn't matter. So you can avoid it also. Then we have some extended requirement like send, delivered, and read recipient of the messages. So like send whenever we are sending some message, that time we see one gray tick is there. Whenever he received it, like it is delivered, so we can see two gray tick. And then whenever the user read it, we can see the blue tick. So we will implement this and I will tell you how we can do it. The next we have a show the last seen time of user. So we can find it out what is the last time when user was online. Okay. So now you can see there is two more things, support file sharing. So I avoided it like first time, okay, because maybe I thought it will create more complexity and authentication like it is very simple feature, so we don't have to add it. But as I discussed and I confirmed with the interviewer, he told me to please add the image video also there and authentication system. So my recommendation whenever you are like just doing any interview, like giving any interview. So just write it down the extra information like authentication also. It will take only a second to write If user wants, like if interviewer want, then he can ask you. Otherwise, no problem. Okay, but you just list it down, so you can avoid the some comments from the interviewers. Okay. Next, we will go for the non-functional requirement. The first is high availability with minimum latency. So here you can see we can discuss about the Pessel theorem. So theorem is nothing like CAPE. We already use consistency, availability, and over the partitions. So same here we are using the PSC, and then we have a ELC. So PSC means simple part. If we have a partition, so availability and consistency is there. Else latency or consistency, we have to take a trade-off here. Okay, so we have to explain. We will explain it. And the next we have a highly scalable handle millions of concurrent users. So we know billions of users using the WhatsApp. So we have to be like create a system. So concurrent user like millions of concurrent user together use it. Okay. Now third is a fault tolerance. Fault tolerance means whenever there is something has happened, faulty things happen and system crash, so we will not lose our data, and that we can achieve using the replicas of our database and systems. Okay, so that we will see whenever we are creating a system. Now we have some design goals, which already I told you their expectation. Read write heavy systems. We have to find it out. Our system is read heavy or write heavy. It will give us more insight to create a system design. Then we have a storage requirement and then sharding requirement and the bandwidth requirement. So this four is the design goals which we can achieve using our estimations, back of the envelope estimations. So here estimations, I have some assumption like whenever we are calculating total writes. So I have some assumption like I'm just creating this system for 250 millions total users. If you want, you can take 2 millions or 2 billion also you can take, 1 billion also you can take. That is not an issue. But whatever you are taking, you have to just calculate according to that. So I'm taking 250 million total users and I'm just thinking 50 million daily active users, that is called DAO, which is 20% of the total. So why this 20%? So we know the Pareto principle, which is tell us 80-20 rules, like 20% public is whatever is doing is affected by to 80% people. Okay, so we are doing a like a 20% active user here. If you are creating a system for the like social media, so you can follow 80-21 principle, like 80% is there, which is ideal public. 20% is like he's just doing the comment and doing some stuff, and 1% only the public which is writing the content in the social media. So that you have to follow. The next we have each user sends 10 messages to four different people every day. Okay. So here I'm explaining like I'm just assuming like 40 message we are sending every day. Okay. And I just assume here like a total 2 million messages per day, like 50 millions user into 40. That is around 2 billion messages per day. So as you can see, I have written here 2 billion message per day, but how we can get it quickly? Because whenever we have to do the estimation, it should be very quick and fast. And I also was very whenever I started this HLD, that time I was very confused how I can do it because it's required very good maths in this. And I think one of my friend also requested me to create the video on estimations. So I'm just covering that estimation here, and we will do the many calculation in this video one by one. So maybe at the end you also be like expert in the estimations. So I will give you very simple way to do it so you can get it quickly. So as this video is going long, okay, so I will not write anything. I already written everything and created a slide, and I will explain everything in detail one by one. So as you can see, we have a estimations basics here. So in the left side, you can think of you can see thousands, millions, billions, trillions, and quadrillions. Okay, so these are the quantity. If you discuss like if you are thinking about the quantities, how much is required, so you can take these units. If you are thinking about the size, So you can take this kilobytes, megabytes, gigabytes, terabytes, and petabytes. Okay. So here you can see we have zeros, 3 zeros, 6 zeros, 9 zeros, 12 zeros, and 15 zeros. So it is the table of three, like 3, 6, 9, 12, and 15. And we will discuss whenever we have something, we will convert it to zero and we easily calculate it. So the same calculation, whatever we did in the last slide, we will do it here also. Calculation of 2 billion messages using the above table. So as we can see 50 million. Okay. So I just simplify this 50 million. So I written here 50 into 10 to the power 6. You can see we have a 60 in the million. Okay. Into 4t. So now what I did, 5 into 4, that is 20. I taken 10 from here. I taken 10 from here and into 10 to the power 6. Now you can see we have three more zeros. So we will convert again it to the power. So now I taken 2 here into 10 to the power 3 into 10 to the power 6 equals to 2 billion message. How? Like 3 and 6. How many zeros are there? 9. And if we go in our table, we can see 9 zeros will show the billions here. Okay. So I taken a 2 and billion. So 2 billion. You don't have to write this much detail there. You just keep in mind and write it down. And if you stuck somewhere, you just quickly write it down and calculate and tell him there is 2 billion messages per day. That's it. You don't have to write this all the thing. But because this is the first time, so we will doing this calculation whenever you are doing two, three systems calculation, you are like do very easily in your mind also. You don't have to write. Okay. So the we already get it like a write estimation 2 billion messages per day. Writes is there. Now we will calculate to total reads. So as 50 million daily active users, we already know approximately I'm thinking 100 messages are read by each user every day. So from morning to evening, I'm checking WhatsApp multiple times. So maybe there is some professionals or some friends message are there. Okay, so approximately I'm thinking I seen around 100 messages. If you want, you can take this, and it is good. You just go by the zeros, like take in the tens. So it is very easy to like calculations. Okay, so I taken here approximately 100 messages. So here we have a 50 into 10 to the power 6. It like a 50 million daily active user into 100. Now we will calculate it again. So we have a 60, 7, 8 and 9 zeros. So whenever we will go to our table, 90 is for the billion only. Okay, so I written 5 and then I apply the billion. So 5 billion messages reach daily. So now we have a writes, we have a read. There is a one formula which we can follow for this, write to read ratio. Okay, so write per day slash like divided by the read per day. If the ratio greater than 1, then our system is write heavy. If the ratio is less than 1, then our system is the likely to read heavy. And if both is equal, then it is the balance system. So now 2 billion divided by 5 billion equals to zero point 0. Like it is the less than 1, then we can say our system is read heavy. So now here we did the justification. We explain very well. Okay, so our system is read heavy. So what is the mean of read heavy? Whenever we find it out our system is read heavy, so we have to solve this issue. How we can solve this issue? We can solve this issue using the caching mechanism. We will introduce the cache in our system and it will help us to quick read. Okay, so it will help us to low latency. And also we can use the master slave application that also can help us. Another thing we can do for CDN, introduce the CDN for the reads. So it is also reduce our reads load. So whenever I get this read and write, we can assume like two, three things here. Okay. So it will help us to create a system. The next thing, request per second RPS. As you can see, I just mention it important point because I forget to mention there and I got a comment about this from the interviewer. So I mention here it is nothing a single line. So as you know we have a 2 billion user here. Okay. Now you can see I just simplify it to into 10 to the power 9 because we know there is a 90 comes in the billion. Okay. Then message per day we are using into what we have to get the second. So and we have a 1 day. So what we will do, we will convert 1 day to the seconds. So approximately if we have a 24 hours and 60 minutes in 1 hour and 60 seconds in 1 minute, then if we into this all 24 60 into 60, then it will come around 86,400. But it is very complex calculation. If we will start with this, we will go with the different things, and I told you we will keep all in the tens. So you just get it out, discuss with your interviewer, tell him because this is the complex calculation, so I'm just keeping it to 1 lakh. Okay, it is easy to calculate and quickly you can find it out the way. Okay, so this is I'm just thinking approximately 1 lakh second in a day, and I confirm with my interviewer also, and he was agree with this. Okay, so we don't have to be perfect on the calculation. It is approximation. If 20% here or there, that is okay. 5 to 10%, that is not an issue. Okay, so whenever I have a 1 lakh, I know in the lakh I have a 5 zeros. So I converted it to 10 to the power 5. This is the sign of power, caret sign. So I write it down 2 into 10 to the power 9 divided by 1 into 10 to the power 5. So the simple calculation, what we will do whenever we have to divide, simply we have a 90 here and 50 here. So we reduce 90 from the 5. Now how much is remain? There we will remain how much? 40. Yes. So I have written here 2 and I apply the 40 here. Keep in mind whatever I am writing here, this is only a zeros. We will not count this 10 because this is only base. Okay. So we are only counting this and this. We are just counting this as a zeros. Okay, so now 20,000 requests per second, we get a RPS, and it will give us more insight why we get the RPS, because RPS is required request per second whenever we are deciding our server, because whenever we are taking the server, that time we know how much requests he can handle. So based on that request we can apply the we can use the multiple servers, okay, for handling that request. Another thing, whenever we are discussing about the database, that time also we know whenever we are using the SQL, so SQL around it will take 100 to 1000 writes per second and 1000 to 10,000 reads per second. If it is going beyond that, then we have to think about the shardings. Okay, so the request per second will tell us we have to go for the sharding. Okay, one thing. And second thing, again we have to choose the system which can handle this much request per second. Okay, now the storage per day. So first we will get the storage per day. So we know we have a 2 billion messages per day and required storage for the text messages per day. As we know, whenever we are sending any messages, we only not send the text, we also send the media also with the message. Okay, so we will calculate both differently because with the every message we are not sending any media. So we will calculate how much we do some assumption, how much message contain the media and how much message contain the text. So approximately all messages contain the text. So I'm just keeping it to 2 billion message per day. Okay, here my assumption is one message approximately 100 bytes because it is belong to the text and it is approximately 100. I'm keeping it to simple. Now I converted this 2 billion to 2 into 10 to the power 9 bytes into 100 bytes. Okay. Now we can see here uh, 2 into 100, that is 200, and we have a 90 here. So whenever we are going to our table, we can see 90 comes for the GB. So we can simply write 200 GB day for the text. Now next we will calculate the required storage for media. Okay. So we are assuming approximately 5% of the messages using the media. This is my approximation. There is no truth I have not did any research. You can approx 10% also. It's on you. Okay, so I'm just assuming 5%. So here I am getting 5% of 2 billion. So I have just written down same 2 into 10 to the power 9. I'm just displaying like this billions into 5 divided by 100. Okay. So as you can see, this is the 100 million message. So I will tell you how you can calculate it. Okay, here. So as you can see here, I just written down quickly 2 into 10 to the power 9. Okay, and here we have into 5 divided by 100. Okay, so now here we have a 9 zeros and here we have a 2 zeros. So what we can do whenever we are doing the divide, we'll reduce these 2 zeros from this 9. So the new calculation comes equals to more simplifies version, this one here. Now we reduce to 0 from here, so now it is 7 0. So as you know, either we can take 6 0, either we can take 9 zeros. Here we have a 7 0. So what we will do, we will make it to 6 and we will add 10 here because every 0 is equal to tens. Okay, so we get 1 0 from here. So now we have a 6 0. So we will make it into 10 into 5, it is 50. 50 into 2, it is 100. And we have a 6. So whenever we are counting, we will look our table. There we can see we have a millions. So I have written here 100 million messages. Simple. So now we get it out 100 million message, which is we are sending as a media. So now we are calculating size. So I'm just assuming like 100 kb size of each media per message. So why 100 kb? 100 kb like there may be an image or there may be a small videos, okay, that we can think of. So I'm just thinking 100 kb. I'm not going 1 MB, 5 MB because that is too much big calculation. So keep it short because we have to do it very fast. So 100 kb that is enough. So before this we have taken 100 bytes. Now I have taken 100 kb like 1 lakh bytes. So I convert the same thing. We have a 100 million. So here you can see 100 into 10 to the power 6 because in our table whenever we have a 60 that is million. Okay, so now we have written the simplified version into 100 into 10 to the power 3. Why 3? Because here we have a kb and kb is around 3 zeros. So we are writing 10 to the power 3. So now we will into it 100 into 100. As I told you, we will just calculate the left side value. Right side value only a 0. So we will calculate 100 into 100, that is 10,000. And I have written 10 to the power 6. And here I have written 10 to the power 3. Now we will simplify. We can see we have more 3 zeros. So we can convert it to the power again. So now we have a 10 into 10 to the power 3, 10 to the power 6 and 10 to the power 3. Now we will count all the zeros. 3, 6, 9, 3, 12. So whenever we are thinking on our table, we are going there, that is 12 zeros. So where we can get is 12 zeros. Here we have a 12 zeros. And if we are thinking of the size, that is TB. If we are thinking of the counting, there is a trillion. So we are doing the size calculation. So we can simply say TB. Okay. So here we have a 10. I have written here 10 and we have this 12 zero. So it is converted in the TB. So simple calculation 10 TB a day. So we already get it out media per day. How much space it will take? It will take 10 TB. Now we are creating a scalable system and we are thinking around 10 years, whatever we estimated here, it will work for the 10 years. So we will approximation we will do for the 10 years. So as we know, in a 1 year we have a 365 days. Okay. So we have a data for a 1 day, like how many message we are sending, how many space is required for a 1 day. So we have to get 10 years. So we will convert 10 years in the day. So we know 365 days in a 1 year, but if we will take 365, then it gets complex. So I just make it to 400 for simple calculation. And I also confirm with my interviewer, because whatever take action you are taking, whatever you are assuming, please confirm every step with your interviewer and engage him. Don't calculate everything on your own. Okay. So now 400 for a 1 year. So how much for 10 years? That is around 4,000 a days. So we have a 4,000 days into 10 TVs. So total it come around 40,000 TV for the media space, and we have a 4,000 into 200 GB a day. So around 8 lakh GB text space is required for us. Whenever we are just sum both the value, so we first convert this GB to TV. Okay, always reduce the units. Okay, so here convert GB in the TV. So we are doing it 8 lakh GB divided by 1000, it come around 800 TV. So as we know, like KB has around 1000 bytes, and 1 MB has around 1000 KB, and 1 GB has around 1000 MB, and 1 TV has around 1000 GB, and 1 TV has around 1000, sorry, 1 PV has around 1000 TVs. Okay, so same thing, we divided by 1000, and this 30 is gone. Now we have end 800 TV here. So total storage required 40,000 TV plus 800 TV equals to 40,800 TVs. Now we will reduce this also. So divided by 1000, now it is converted to petabyte. So approximately 40 petabyte is required for 10 years for saving the messages. Okay. So we, as I told you, we don't have to go exact. So as you can see, we reduce three zeros from here, and now we have a 40 approximations. So we get it out how much space is required for 10 years. Now the next we are doing the bandwidth requirement. So the total storage requirement a day for 2 billion messages is media 10 TB and text around 200 GB, which we will convert divided by 1000. So 2.2 TBs. Total space is required for 10.2 TB a day. Okay, and whenever we have to get the bandwidth, we will measure the bandwidth in the seconds. So first we have to convert this in the seconds. So we have a 10.2 into 10 to the power 12 bytes. It is the TV, because we know in the 12 zero, TV has a 12 zeros. So I have written 12 here, and 10 to the power 2, I get it from here, divided by 1 lakh second, as assuming one day has a 1 lakh seconds, and we divided by 10 to the power 5. I converted to 10 to the power 5. So it is very easy to calculations. Now we have written 10.2 here into 10 to the power 12 we have, and here we are dividing, so we have a 5. We will reduce this 5 from this 12. Now we have a 7. The same calculation we will do. 10.2, we have taken 1 0 from here. We converted it to 10 into 10 to the power 6. Whenever I am doing this calculation, this come around 102, and if we have a 6 zeros and we are going for the size, then we can convert this to the MB. So we have a 102 MB seconds. So as you can see how much easy calculation using our tables. So just keep remember, it is very easy. If you are not like thinking, you not able to remember it, that is not a problem. You need KB, quickly you just see KB, MB, GB. Fat, fat, fat. Okay, like this you can remember quickly. So as per our requirement, whatever is there, we have completed bandwidth also. So till now we have completed our read write heavy system, and then we have completed our per second request. Then we covered our estimation for the size of whatever is required there, and then we have covered the bandwidth requirement. So bandwidth requirement is very important statics which we can get it, and it will tell us like if we have a 102, okay, like whenever we are discussing about the video, that time it can be in GBs. So to solve this issue, what we can do, it will tell us we have to use the CDN, because CDN has a multiple all over the world, multiple system. It may be a lakhs of system, which is like that's like Cloudflare is there. Okay, the big giants are there, which has created this network, and it is used by the different many industries. So as we can see, around 75% of load of the internet, this CDN is taking. So we also can use to reduce this bandwidth, the CDN use. So in the whenever we are creating a system design, we will consider the CDN. So whatever calculation I am getting, this all will give us some insight of our system design. So now justification for design goals. As we know, there is four goals we have for the design. That is the read heavy systems. We know we already shows our system is read heavy. To solve this, we have to introduce caching in our system. Next, high storage requirement. It will tell us we require some large file system which where we can manage and store our media files. Then we have a high bandwidth requirements. So the CDN which can help us to reduce our bandwidth. So we will introduce CDN in our system, and sharding is required. We know we are just handling the big data, so sharding is also required, and we will discuss more on sharding in the next slide. Okay. So I have seen there, I told you, I also surprised that time whenever I encounter this issue, because I got some feedback on the schema also. So I have given one or two tables, but he was expecting me to just give all the tables. So I have written here for the WhatsApp for your reference. So you can see we have four tables here, but I did some optimization. Like as you know, the MVP, we have two things. One is one-to-one chat and one is the group chat. Okay. So into one-to-one chat, like we have to maintain more table for the one-to-one chats, and we have to maintain the separate table for the group. So like there may be like 7 to 8 tables. So I reduce the tables to the four. So what optimization I'm thinking of, like we can use the group ID for all the chats. So for personal chat also, like one-to-one chat, we are thinking a two people group. So we are not using the chat ID, we are using the group ID everywhere, wherever we are doing. So it is very easy in optimized ways, because whenever we are finding using the chat ID, then it is the fan out query for the group, because if there is 100 member in the group, as we mentioned the constant there, so it is going to hundreds. Like if you do using the user ID, then it will go to the 100 shardings. Okay, so it is very bad for the optimization. I just remove that chatting ID, and I just keep and thinking everything is the group here. If we have a one-to-one chat, then that is the two-person group, and then another normal group we have. So we maintaining here users table, where this user table maintaining all the authentication and profiling related things. Then we have a group where we are creating a group, and special we have written here type, which have two fields, group and personal. It will distinguish it is one-to-one chat or it is group chat. And then we have a member count. Now we have a one mapping table which is called the user underscore group table, and here we have a user ID and group ID, and here it has a coordinality, because I have discussed one of my friend, and he told me the interviewer asking the coordinality also. So I'm just mentioning here, whenever you are giving any schema, you have to do this also. So this is the N to M, like M to M many to many relation with the user group table. Okay, and we have one table for the message, where we have a ID, user ID, group ID, contain, sent it, deliver it, and seen it. This is the three important thing which I told you. We added some extra features, extended features for our system design, like last seen, when it's sent, read or not read, that we will maintain using these three fields. Now we have to do the just give the justification what we are using, SQL or no SQL. So as you can see in the previous slide, this slide, it look like a SQL. It look like it is very it is required some joins and it is tightly coupled. But as we can see, our system is very big and we have to deal millions of request. So SQL is not capable to do that, but there is some like ACID property which we have to use, like joins we have to use. So what we will do, we will take a approach to use the hybrid mode. We will not create one single database to handle it. It is very like hard to scale. We cannot horizontally scale if we are using only SQL. So we will take a SQL and non-SQL combinations. So we will divide our tables in two scenario. One, user and groups we will keep in the SQL, and chat and media we will keep in the non-SQL. So we can horizontally scale this thing, and this is the big amount which we have to handle. And whenever we are doing horizontal like scaling, so we have to go for the sharding. And sharding is required a key. So as I told you, I avoided the chat ID. So now we have a group underscore ID. And based on the group underscore ID, we will do the sharding. So we have a sharding key also with us. So now we did a justification for the SQL and NoSQLs. Now next come to the API design. Here also I get the comment because I was thinking two API only, get message and send message. So I explain in get and send message. Then I got some comment from there. So I added all the API whatever is required there. So first API is get all chat required. Okay, here we have a get all where we will send the group ID and we will get chat and group as a list. Next, we have a get message. So get message API, we will send the group ID and session ID. So what is the session ID like? Whenever we are discussing with someone, that is called the session. So one chat is one session. So we have session ID for that. So we will send the session ID, group ID, and we will get the list of messages from there. The next we have a send messages. In the send messages also we will send the group ID and send ID, and we will send the messages. You don't have to go inside what we will send in the message because this is the high level design. It is not a low level design, and it will return as a boolean. Now next we have a join or leave a group. So two more is there. One for the join where we will send the group ID and session ID, and boolean we will get it, and leave group same we will send the group ID, session ID, and we will get a boolean. So these are the APIs and tables. You don't have to worry about in much detail. If you are not come up with this thing like schema and APIs, you just take help of the chat GPT, give your solution and ask him to write it down, and it is more than enough to explain to the interviewer. Okay. So these are the things which we already completed, and our four steps is completed, starting from the first thing is the problem statement, second is the requirement gathering, okay, the second is a functional requirement, and third is a non-functional requirement, fourth is a design, and we have to justifications, and now the final point, high level design, we are here. So first we will discuss architecture. So we are using the microservice architecture which will help us to horizontal scaling, and we have five services. One is a user service, which will take care of your all the authentication. Next, we have a chat service, which will take care of sending message and receiving messages. Then we have a notification service. This I will tell you because I forget to add there and I will get comment on it. For this, I should have to use the Kafka, and I have not written there whenever I created my system. So I mention here, if you are facing the same, you just add this. It is very important. Then we have a presence service. As I told you, we have to find it out the last last logged in, this a last active. Okay, so that we can use using the presence services and media services. So whenever we are uploading and watching or downloading anything, we will use these services. So there are five services. Now, whenever As we told, we are using the microservices for horizontal scaling. So how they communicate to each other? So they will communicate using the REST or HTTP API. There is one more thing which is very optimized and nowadays using gRPC, but I will not go in detail. If you want to see, just go there on internet and see how gRPC is used for the communicate to the uh, this services. Okay, now we have next thing, the very important thing, and just keep attention, just focus on this thing, how real-time messaging work. Because as we know, HTTP only can send a request to the server, but server cannot send the data without request to the client. And that is the issue whenever we are discussing about the real-time messaging works. Okay. So there is two method is working. One is the pull mechanism and second is the push modeling. In the pull modeling, normally we will do the like authentic older thing like HTTP request. So what we will do, we will send the request to the server. Server holds the request for a long time, and if there is any new message come, then it will send you the message. Either if there is any timeout, it will send you the like just send you the decline message. Okay. So it is called the long pulling. Okay, and it is like a very overhead, unnecessary overhead, request overhead on server, because we are sending multiple requests to the server and it is closing, then again we are opening. So if we have a small system, then it is okay. But if we are dealing with the billions of user, then we have to think better solution. So the better solution is push model. Push model is using the WebSocket. Okay, so you have to explain to your interviewer. So we are using the WebSocket because WebSocket is a two-way communication. Whenever we are doing the HTTP, this is only one-way communication. You can send request to the server, but server will not send request to you without any request data. Okay, but here we have a push model where we have a open connection between the client and server. So first time, whenever the client send the request, it is the handshake request, and whenever handshake between the client and server, the port is open, and it is always be open for your communication. Whenever you are sending the message, it will take message, and whenever it gets some response from the user, it will send back directly without your request. So here server also can send the response without any request. So this is the important thing, WebSocket, which I mention here, and we will mention in our system design also. So as you know, we have discussed about some last seen features and read features, how we can implement it. So last seen feature we can implement using the heartbeat. Okay, so what is the heartbeat? Heartbeat is nothing. Whenever our we have some system where we are pinging server on every second, okay, and we are checking if we are sending some request to him, and if we are getting some response from the server, then we will take that timing timestamp and we just keep in the caching. Okay, so it will tell us our server is live. So that is the active whenever we have a last seen feature. So we will take it from here. So we are keeping in the cache because we don't want to add burden on our database. Okay, so like heartbeat, whenever we are doing, so the question comes to us like whenever we are doing periodically, like in a second, and we have a millions of requests. So it is a overhead, but it is not a overhead because whenever we are implementing this type of feature, we think about the zookeeper, and it is very easy because it has to only send a signal. It do not have to save any state or do any calculation. So he can handle around billions of requests per second. So it is very easy using the zookeepers. Okay. So this is the one thing. The next thing we can see here, the read feature. It is little trickier because whenever we are sending some message to the user, we will wait for their response. Whenever the response will send us, then we know it read or not. But if the user is offline, then what we will do? In that sense, whenever the user is offline, we will send our message to the queue, And the queue, we are sending the extra information, metadata to it, like what is the client devices and where it is belong to. And whenever the user comes online, it will go there, get that messages, and it will send a response. It is reads by the user, and the server send back to the respond to the client, because it is two-way communications. So now here I have my system, and I will just go here to. So I have created this in the Lucid chart. Lucid chart is a very good application. Also, we can create in the draw.io, but I think draw.io do not have that much facility what we have in Lucid chart. But draw.io is free, but Lucid chart had some limitation like two, three we can create. And here I have to create only one, so I have created here very nice colorful thing. So as you can see in the left side, we have this different type of shapes. And if you want to search something, you can go there and type mobile. Okay, and whenever you click on this, it will give you the icons. You can take and use it here. Okay, so you can use it. If you want me to just draw it from the screen, just write it down in the comment. I will create a separate video for that because this video already too long now. Okay, so I will explain quickly and we will finish it. So control plus and control minus you can do for the zoom in, zoom out. And there is a space bar. Just press the space bar and using the mouse you can move it. Hand icon will come. So as you can see, we have a client here and we have a laptop, phones and different type of phones. And we have written here WebSocket. Whatever request we are sending as a WebSocket we are sending, and it is taken by the API gateway. Okay, and there is two routes. First is if the user is not logged in or not registered, first it will go to the user service, and user service will go to the load balancer. Okay, so if there is a registration, it will save the data to database. Otherwise, if there is a login, it will get the response. As you can see, here we have a two arrowheads. Okay, so as you can see here, we have a database and replica. So we discuss the second point in the non-functional requirement around the fault tolerance. So to fault tolerance, what we can do, we can use the replicas. So I'm doing the replicas of database. So I'm using here master slab applications where we have a master where we are writing it, and to reduce the load of reads, as our system is read heavy, so we are reading directly from the replicas. Okay, and it will fault tolerance also. So we solve that issue also here. So whenever the user is logged in, and it will come to the chat service. The chat service has two routes, one for the load balancer and one for media. If it has a media, it will go to this routes. If it has only text, it will go to this. And here we are maintaining three things. First, we are maintaining database. Second, we are maintaining messages queue. And third, we are maintaining caching. Okay. So I'm just, whenever the text message will come, if it is a new, then I will just store in the database. Either user online, I will send it to directly. I will just send to this message queue to send them. The notification service take care of it, consume it, and if it is online, the user, it will send. If it is not online, then it will keep waiting for that. Then the second thing, I have a caching. So if like this is the history messages, I can take it from there. If it the new message, I will store in the database. If it has some like media, so I'm taking this route, and here we have a media services which will process this all the items. And as you can see, we have two things: large file service, it can be S3, and we have a CDN. So whenever I make it to minus small, you can see we have a big blue box. So whatever I have inside of this box, that is belong to our system, and whatever I have outside of this, that is the third party service we are using. Okay, so you also follow the same to creating it. Now we have one more thing. I told you we have presence services. So one route, whenever you are coming, you want to check whenever the last seen. We will go this route in the chat services, and here you go to the present services. Present services go to the load balancer. We have a caching mechanism. It can be a multiple. You don't have to show multiple boxes here. You confirm with your interviewer. So I'm assuming we have a replicas of this caching and multiple servers. So I'm implemented load balancer here. Load balancer will get the last scene from the caching, and we are using the caching for the last scene because it is not required to be perfect. Like if I was active on the like 10-10 and it is showing me a 10-8, that is also fine. Okay, that is not that much important exactness there. So we are using the caching, and caching is very fast. Okay, so here we have a low latency also. So here you can see the complete system design I have created, colorful. If you have time, you just spend time and do the great thing. If you do not have, you can make it to black and white. That is also fine because he just want to see your approach, how you are creating. And as you can see, we have covered all the things, whatever we have discussed from the starting. 14 points, all we covered here, and we have created fault tolerant system. We have maintained the caching, and we also maintain here queue, which will give us the facility for the asynchronous operations. So the next feedback given by the Saran Balaji from the Microsoft: requirement gathering good, come up with the most of the requirement, scale estimations good, but need to estimate QPS, which I already told you, query per second. APIs need to come up with extensive list of APIs. As I told you, I given him two. He was expecting more to me. So I listed down all the here. Then design good understanding of components. As you can see, I have written all the components there. Need to mention about asynchronous process using Kafka, which I forget to mention, but here I already mentioned the Kafka queue. Okay, so now I successfully cleared it, and happy moment. The next thing, how do I prepare for this my interview? So I spent 4 days reviewing my notes on HLD, four to refresh my knowledge. This give me two confidence to give the answer of their questions. And also I practices like Disney Hotstar system design, job application system design, type ahead system, and Uber system. These are the important which you can consider. If you need any other system like Disney Hotstar or something, just let me know, come in the comment. I will create another video. I also created one Disney Hotstar system also, and I will create system for that. But you have to comment to me. Okay. So I think it is done from my side, and I have created a very detailed note around 150 pages. So I will attach all the notes and this PDF also with this video description. So that's it for today's video. I hope you learned something new and exciting. I dedicated 2 days to create this video, so I hope you find it valuable. I kindly request everyone share it with your friends and classmates as this can help others prepare for their interviews. Please like, share and subscribe. Thank you.